we are going to learn we're going to be like weathermen. We are going to predict precipitation. Okay? But not the precipitation, not the rain kind, not the snow kind or the hail kind. How sleet it is? No, not going to be sleet. No, we're talking about precipitation in a chemical reaction. So what do all the things I listed as precipitation have in common? Okay. So I included rain, snow, sleet, hail. What do those all have in common? The clouds and water, okay. Okay, now I'm going to tell you that fog does not belong on the list. Well, fog is water. The difference between fog and the other ones is the other ones fall from the sky. Fog doesn't fall from the sky, right? So precipitation is the water that falls from the sky. In a chemical reaction, precipitation is the solid you make in solution that falls to the bottom. Hey, so yesterday we put together the iron 3 nitrate and the sodium hydroxide and made the iron 3 hydroxide. Well, look where it's at. It's at the bottom of the test tube. Solid went down to the bottom. Iron 3 hydroxide was a precipitate. It fell out of the solution just the way rain falls out of the sky. That's why they picked the word precipitate for it, because it falls down. Those are the ones that we use the down arrow for. Instead of writing the word solid, you see how a down arrow would describe what happened to FeOH3? Okay. So that's a precipitate. So you've seen precipitates before, you just didn't know the word precipitate was the one for them. So what you're going to need to be able to do is predict them using some general solubility rules. Now these aren't going to be guarantees that they happen. This won't cover every situation, but it'll get us in the ballpark. If we really want to know for sure, we actually have to mix the chemicals. But you can predict it pretty closely if you know some rules, or if you know how to apply the rules and have access to them. You do not have to memorize these. It will be printed on the tests, and you'll have this paper when you do the homework. Actually, I think I even printed on today's homework. I'll be back with more. Let's get in the back row. Oh, actually, right here. So there are the general rules for solubility. Solubility, able to be solution. Solubility, able to be dissolved. You got to. No, the machine got it wrong. Hey, so this is the list. Okay, so you'll have access to this. You just need to be able to use it. Okay, so the first thing it starts off with is these things are soluble. You've got this on the piece of paper. What does soluble mean? Soluble mean is dissolves. Soluble means not a solid. Okay? So anything, and salt is the generic term for any ionic compound. So it says salts with alkali metal or ammonium. If they have alkali or metal or ammonium in them, they are soluble. They will dissolve. Okay? And that's the only rule that has anything to do with the positive pieces. So I check that one first. Okay? The positive piece is an alkali metal, which is group 1A, and it is an ammonium, NH4+. Then you move on to the negative pieces. So the rest of the rules are about the anions. Okay? Salts of nitrates and chlorates are soluble. So look at the negative piece. If it's nitrate or it's chlorate, it will dissolve. And that's going to apply to things like nitrite and chlorite as well, right? We don't want to list all the possible ways, like endings for that, so we'd expect nitrites to be soluble, we'd expect chlorites, we'd expect hypochlorites, we'd expect perchlorates. And actually, this causes a problem here. It actually is a problem right beneath your feet, because some of the wells that they get the water from here in Rancho Cucamonga are contaminated. And they're contaminated with rocket fuel. And the solid rocket, the shuttle went up into space, had those 2 solid rocket boosters on the outside. The solid rocket fuel was made here in Rancho Cucamonga. Ammonium perchlorate. Ammonium makes it dissolve. Perchlorate makes it dissolve. So if they spilled any and it rained, it dissolved and got carried down into the groundwater. And once it gets into the groundwater, you can't get it out. You can't put stuff down there and turn it into a solid so you can filter it out, because it always stays dissolved. The only way to get rid of all that ammonium perchlorate in the water, it's not the ammonium, it's the perchlorate that's the problem. The only way to get rid of it is to get rid of all the water and pump that someplace else, so you can contaminate someplace else with perchlorate. Okay? So there are wells we can't use here because they made rocket fuel in the 80s. Okay? And the fact that it stays dissolved means we can't get rid of it. Okay? So bizarre applications of it. Okay, salts of sulfates. And here we have something different, except if they're with specific ions. If they're with those ions, that means they're going to be solid, because it says they do dissolve unless they're with those. Understand that wording? So calcium sulfate I'd expect to dissolve. Silver sulfate I wouldn't, because silver's on my list of things that are exceptions to the rule. Okay? Now I expect the same rules for sulfites as sulfates. Okay? Salts of chlorides, except silver, lead, and mercury. Okay, chlorides, and I expect chlorides. The rule they say about chlorides, I expect to follow for everything in the halogen group. They don't want to list chlorides, iodides, bromides, fluorides. Okay. Notice that's an IDE ending. Every other one's an ATE ending. So watch those endings. This one's about something off the table versus polyatomic, so it says chloride, not chlorate. Different things. Okay, and those are all the things that will dissolve. And the last rule is about the things that won't dissolve. These things are not able to be solution. See, I tear that word apart. In, not, bull, able to, solu, be solution. Oh, you didn't give those? Well, that's going to be really hard for them. They're writing fast. Okay. So, carbonates, phosphates, chromates, sulfides, hydroxides. But that leaves us with a potential conflict. What if I have something like, is it on the board right here? No, we got rid of it. Oh yeah, right here. Na2CO3. Would Na2CO3 dissolve in water? Well, if I look at my rules, I've got a contradiction. Na is a metal. Rule number 1 says it dissolves in water. CO3 is carbonate. Rule 5 says it doesn't dissolve in water. Which one wins? The answer is rule 1. That's why it's rule number 1. Because you apply it first and then you never have to worry about any of the other rules. Once you find sodium, you know it's going to dissolve. Doesn't matter what you put it next to. Does that make sense? So all we're going to do is do the double replacement reactions we did yesterday, and then decide if something on the other side is solid or not. So that's all we're going to have to add to is deciding whether things make a solid. So let's do a few. See how to make that decision. Is LiBr soluble? Okay. So could you dissolve LiBr in water? Well, first I look at the first element, Li. Is Li an alkali metal? Yes. What does Rule 1 say about alkali metals? They're soluble. I'm done. Okay, AQ, dissolved in water. So when you see AQ next to it, that means you dissolved it. Will barium nitrate dissolve in water? So I look at it one piece at a time. Barium. Is barium an alkali metal? No. So rule 1 I don't have to worry about. So now I got to worry about the negative piece. NO3. NO3 is nitrate. What does the rule say about nitrates? Rule number 2 says nitrates are soluble. Okay. So according to rule number 2, this is going to dissolve in water. Calcium sulfate. Well, first we find calcium on the periodic table. Group 2A, alkali metal? Nope. So SO4 is called sulfate. What does it say about sulfates? It says sulfates are soluble unless they're with one of those 5 things. Is calcium on that list? No. So it says it's soluble. Everybody see how I'm applying the rules? Look at the positive piece. If it's alkali metal, you're done. If it's not, move on to the negative piece. See which rule is there. PbCl2. Is lead an alkali metal? No. So I got to worry about the negative piece. The negative piece is Cl. Cl is chloride. What does it say about chloride? It says chlorides are soluble, except if they're with silver, lead, or mercury. So this is going to be the solid, because in Rule 4, it's one of the exceptions. So see how Rule 4 tells us that PbCl2 is going to be solid. Chlorides are soluble unless they're with things like lead, silver, or mercury. It's with lead. So it's going to dissolve because of the chloride. But except silver is an exception to that, so it won't dissolve. It's going to be a solid. So I put a solid next to it because chloride with lead makes solid. If you read Rule 4, that's what it says. What about CaCO3? Well, is Ca an alkali metal? Nope, it's 2A. CO3 is carbonate. Carbonate is down there in rule number 5. It says it's going to be a solid. What about K2CO3? Is K an alkali metal? Yes. But I know K is an alkali metal, but we just said carbonate was the solid. But it doesn't matter. Rule number 1 wins. Rule number 1 always wins. Okay. Will that dissolve in water? CdClO3 2. Well, Cd is cadmium an alkali metal? No. ClO3 is called chlorate. What does the rule say about chlorate? Says they're soluble. Rule 2. Does it say chlorates are soluble? So all you got to do is able to apply those rules. Let's see an application of that. Here. So here I have a solution of lead 2 nitrate, and potassium iodide. 2 clear solutions. So potassium iodide in. Add the lead 2 nitrate. It would just be darker. Hey, did something happen? Hey, can you see through the yellow stuff? No, that tells you that there's a solid in there. Okay, that's what's blocking the light is the solid. What's the solid? What's the solid? We should be able to figure out what the solid is. Okay, we know it made a solid. Let's figure out what it is. So I had PbNO3 2, had that dissolved, and I reacted it with Ki. What am I going to get for products? Well, so it's double replacement, so K and Pb are going to switch places. So Pb will end up next to I, and K will end up next to NO3. So I did what the name says, double replacement. Then I do charges, K is 1 plus, NO3 is 1 minus. That's the right formula. I is 1 minus on the periodic table. Pb, I got to go to the other side of the equation. Since nitrate is 1 minus, and there were 2 of them, I got 2 negatives. So to add to 0, Pb had to be 2 positive. If it was 2 positive there, it's 2 positive there as well. That means I need a 2 there. To balance it, I just put 2 next to I, so I got to put a 2 next to K. That gave me 2 Ks, so I put a 2 next to KNO3. That gives me 2 NO3s, which I had already, 1 Pb on both sides, and we're balanced. Okay, so what's the solid? Okay, so first, the solid would not dissolve in water, right? So it's either got to be PbI2 or KNO3. We're down, it's got to be one of those 2. Is Pb an alkali metal? No, so I'd have to use another rule. Is K an alkali metal? Yeah. So we know KNO3 is aqueous. And since we know it made a solid, and it's not KNO3, it's got to be PbI2. That makes sense? That's how we knew which one it was, because we knew which one it wasn't. It wasn't KNO3, so it had to be PbI2. It had to be one of those 2. Okay? Say, but our rules, what are our rules going to tell us that it's PbI2? Okay, Pb is not an alkali metal. I is iodide. What rule talks about iodide? None. But what rule talks about something like iodide? Something that would behave just like iodide. See where it's rule 4, the chlorides? And see how lead is an exception to the chlorides. So we'd expect it to be an exception for the iodides. Because I expect chloride and iodide to behave the same, because they're in the same column. Okay. So that organization, the periodic table, makes our life easier and later on in other places. It keeps showing up. We're not done looking at the things in the same column behaving the same way. Big chemistry idea. Yeah. All right. So now we're going to be able to answer, with double replacements, is there a reaction? Single replacement, we can use activity series. Double replacement, we can't. Because with a double replacement, there's going to be one on top and one on the bottom, but there's also going to be one on the bottom and one on the top. So if a double reaction is going to happen, double replacement is going to happen, it's going to make a gas, a solid, or water. What making one of those does is we started off with a whole bunch of ions. Any one of those is going to remove the ions from where you're at. A gas is going to bubble away, and whatever ions you have, they've now left the solution. A solid, okay? A solid. Now this is yours. You started to see that it's getting darker towards the bottom. But last period, I did it. The yellow's really piling up on the bottom. Eventually, the whole top will be clear, and you just have yellow powder on the bottom. Okay. These are the ones we put the down arrow for, because they sink down. Okay. So that solid separated itself from the solution. It took the ions away. Water would take the ions away, because water takes away an H plus and an OH minus. Right? It takes one of each. So since water takes one of each, it's going to get rid of the H plus and OH minus. So water is always going to be made from an acid, something that starts with H plus, and a hydroxide. Because you're going to have H plus on one chemical and OH minus on the other chemical, and when you do the swap, you're going to put H plus next to OH minus. You did that a lot. It happened about 4 or 5 times on last night's homework, where you put H plus next to OH minus. Those reactions were going to happen because they made water taking the H plus and OH minus out of solution. You're not going to be able to predict if it's going to make a gas, but now we can predict if it's going to make a solid, because we just learned how. So all we have to do is everything we did yesterday, and then decide whether one of them is a solid. So you have to do the exchange, the ions, see if one of the pieces you make doesn't dissolve in water. Because when you do the exchange, you'll see if you made water. And you can then you can check to see whether you made something that wouldn't dissolve in water. Hip. When you leave here. So, like here. We've got this one from your homework last night. All we're going to do is say, okay, we do the exchange, we write the formulas, and now, is either one of these going to be a solid? Well, is Ba an alkali metal? No. Is Na an alkali metal? Yes, Na is an alkali metal. So rule number 1 says that this one's going to dissolve. So I'm done with that one. I don't know, CO3. CO3 is carbonate. Carbonate is rule number 5. Rule number 5 says carbonates are insoluble. So this reaction is going to happen because it makes solid barium carbonate. Make sense? So we're just going to add does it dissolve or not to the end of once we've done the double replacement. So If I put together MgSO4 and NaOH, is there a reaction? And if there is, why? So MgS, magnesium sulfate and sodium hydroxide, the magnesium and the sodium are going to change places. So the magnesium is going to end up next to OH, and the sodium is going to end up next to SO4. I did the double replacement. Put them next to their partners. Now I got to write the right formulas using charges. Mg is a group 2A, so it's 2 plus. Hydroxide is 1 minus. I looked it up in the back, my periodic table, so I need MgOH2. I need the parentheses, so I got 2 OHs, not just 2 H's. Na is 1 plus, SO4 is 2 minus, so it's got to be Na2SO4. To balance it, I put 2 NAs, so I got to put a 2 in front of NaOH. That gives me 2 NAs and 2 OHs, which I wanted anyway, 1 magnesium and 1 sulfate. We're all balanced. Now I'll have to decide, do these dissolve in water? Because neither one of them is water. Right, you don't see the formula for water up there. So is Mg an alkali metal? Is Na an alkali metal? Yes. Oh, yeah, it's a group 1, right? So Na2SO4 is aqueous. It's going to dissolve in water. And so now I need to worry, said Mg wasn't, so OH is hydroxide. Where's hydroxide show up on your rules? Number 5, right? Number 5 says it's going to be a solid. It's going to be insoluble, not able to be solution. So these are the ones I would expect that magnesium hydroxide to fall down out of solution. So that's why we use the down arrow for solid. So this reaction is going to happen. It's going to happen because magnesium hydroxide is a solid. H2SO4 and KOH. Well, the H and the K are going to switch places. So H is going to end up next to OH, and K is going to end up next to SO4. SO4 is 2 minus, K is 1 plus, so it's got to be K2SO4. H is 1 plus, OH is 1 minus. Is this reaction going to happen? Yeah, it's going to happen because we made water. Now, we could have made a solid too. That's a possibility. So is K2SO4 going to dissolve in water? Well, K is an alkali metal. Rule number 1, we're done. So the reason why the second reaction happens is because it made water. Something that starts with H. What the heck? Why did it jump there? Something that starts with H reacts with something that ends in OH. It's going to make water every time. K3PO4 plus FeF3. The K and the Fe are going to switch places. So the K will end up next to PO4. And the Fe will end up next to PO4. Oh, F. Sorry, next to, oh, that was right. PO4 was right. The first one's wrong. It's got to be F. Sorry, next to, K is next to F. Okay. K is 1 plus, F is 1 minus. So that adds up to 0. PO4 is 3 minus, I looked it up. Fe, I got to get the Fe from the other side of the equation. Since F is 1 minus and it took 3 of them, I got 3 negatives on this side, so the FE had to be 3 positive. And if it was 3 positive on this side, it's 3 positive on that side. Okay. So that adds up to 0. Now all I have to do is balance. 3 Ks, so I put a 3 in front of Kf. That gives me 3 Fs, which I wanted anyway. 1 Fe, 1 PO4. Now, is either one of those a solid? Well, is K an alkali metal? Yep, so it's aqueous. Is Fe an alkali metal? No. So then I gotta look at PO4. PO4 is phosphate. And rule 5 says that that's going to be insoluble, so that's going to be my solid. Does that make sense? So all we're doing is the double replacement and then trying to find the solid on the product side. Okay? That's what your homework's going to have you do. You're welcome. That's what your homework's going to have you do. It's going to give you some equations, tell you to complete and balance them, and then identify what the solid is. Sorry. It's only got one side. Surprise, surprise. Because it asks you to do two things.